Hello, everyone, and welcome back. And we are getting right along into our program here. And so I am so excited to introduce Nir Paz, product management at Standard AI, here to talk to us about API security and something near and dear to my heart, doing more with less. Hey, Nir.
Can you hear me? All right. Can you hear me? Hello? Can you
Yeah,
hear
there
me?
you are.
Yep. All right. Cool. Hi. So my name is Nir Paz. Thank you for having me here. I want to talk a little bit about doing more with less specific, and I'll tell you exactly why. I am coming from a company called Standard AI, which is not a cyber company. And um, this is a company where we're building a vision platform that basically we turn everyday spaces to extraordinary experiences. It's the world's most advanced autonomous retail platform. But basically, we allow shoppers to come into a store, do their shopping in minutes, and check out in literally seconds. And you're probably asking, okay, so API security, how does that relate to what you guys are doing? I'll tell you. Basically, a problem shared is a problem halved. It's a pretty known proverb. And API security or API is something that we all use. So everybody has an issue with security or securing APIs, and everybody is using APIs. So by being here, basically talking to you about that, I'm going to share what I've seen, what basically is being done in smaller companies, and which may have less resources than big corporations. So generally, why invest at all at in security for APIs? So we all use APIs, like I said. In a company like Standard, we use multiple APIs. We have many third parties we work with. We have our own APIs, and APIs essentially lead to a lot of data. That's essentially what they do. They simplify things for us. They're very efficient, very effective at what they do. But this is kind of what makes them a convenient vector for attackers. So they're easy to work with, and they get you a lot of data for better or worse. So in order to use that tool properly, we need to make sure that it's limited in a way that cannot or will not cause catastrophe. So APIs in nature are vulnerable, like many other things, but because they do what they do, they use various protocols for us. They do a lot of translation. We have different type of request formats, and different responses that we're getting. They basically require a lot of investment on the design phase. So essentially, it's very easy to make a mistake with APIs. Essentially, you can just ask for data that does not exist or provide data that you should not, and it will still work. And you won't really know that there's an issue unless you are really looking into it. So it requires a lot of investment in the design, more than other things. And also, security isn't really top of mind many times when you either implement or basically design API. Many times you work with a third party, you basically get what you get their API, and you just use it as is, and either count on some third party to secure things for you, or you just see that it works and leave it as is, leave it there. So essentially, that's a vulnerability. It allows you, it gives you a false sense of security because it's working. So is it working as intended though? And then the last thing, other than the fact that they're vulnerable, you want to invest in security, specifically in APIs, technically because it also saves money. So I'm not even talking about reducing likelihood of a breach, which will cost you in insurance, either premium or retention. It will You will need to spend incident response resources. You have your brand equity you need to think about. There is potential downtime. Regulations depend on the industry. You may get fined. Sometimes you need to pay a ransom. That really depends. There are many downside for a breach. We all know that. This is not new. These are not news. Um, but this is basically, this is a cost. It is a cost center. And then maintenance, operation, and support. When you design your API in essentially, let's say, sloppy way, then you will pay for it later. There's going to be a technical debt. It's going to be hard to maintain. New people that are going to manage the API are going to be, it's going to be more difficult for them to kind of understand documentation, what the API exactly do, what is the context. So you will pay for it later on. And then lastly, compute resources. If you allow many requests or many responses, even if they're benign, even if you just drop them, but the fact that you allow that through a gateway, for instance, you will pay in compute fees. So essentially, by dropping some of these illegitimate or improper requests early on, essentially you'll be saving some money. This is not the main incentive to do API security, of course not. However, it does have the potential of saving costs. And this is gonna one of the one of the main conclusions here. On the design phase, you make most of your investment when it comes to API. You can add tools later on, but on the design phase, if you made a mistake, if you design an elevator like this, it will be very, very hard to fix it later, to maintain it later, to support it later. So essentially, what does that mean? Okay, we get it. We need to invest in design. We need to think about it. That basically means that we really need to be proactive here, because if you just design the API and it works and it's either effective or efficient, and essentially you're done, you are not going to have a secure API, or you may basically spend more than what you actually want to spend. Now, here there are some common security risks that are coming here in API, and I want to give first of all a little shout out to OWASP API Security Top 10. There's a release candidate for 2023. This is probably going to be on another talk here. Basically, what they do, they put in the most common API security risks. What I was trying to do here is basically to bring in and kind of categorize a bunch of risks that may not be the most common, but are the things that I've seen happening over and over again. Some of them are in the most common list, obviously. And I basically distributed it in 3 different buckets. So essentially, the things that are broken, the things that we do too much of, and the things that we do too little of. So the broken things here are user authentication, which is essentially just to authenticate who is making the request for the API. You can literally build APIs with no authentication. So basically, just allow everybody to come in, make requests, and get responses, which obviously is a broken way of doing things. But there are many, many ways to basically break the authentication and allow somebody to pose as a different user. We're not going to get into the methods of doing that here, but this is one main thing that is broken in most in many different APIs. Why, you ask? Everything here that you see, like the broken in the broken section, it really depends. But many of the APIs are being served as either internal or the data that they provide is deemed extremely benign and not super important. So if it's an internal API, nobody knows how to access it anyway, kind of security by obscurity, and that's okay. We don't really need to build something for it, or it's already behind some kind of a, I don't know, some kind of a gateway. So that's okay. That we can use that as a first and only line of defense. But this is it's a, let's say it's a bad approach. We do need to implement the user authentication to make sure that only the authenticated users can properly access. Object level authorization and function level authorization, these are two authorization issues, two separate ones. The first one is basically if you tamper with some kind of an identifier, so you can access basically on the object level to another user account or to another user's data, and essentially get access to information that you're not supposed to, either by mistake or maliciously. And the second thing is a function level. So that basically means that you can, an attacker can essentially execute some commands or access some endpoints that are only available to specific privileged, typically accounts. And essentially that means that you can perform actions on data that you're not supposed to, even if you don't access the data. So I don't know, drop a table, for instance. So this is the third item here. Next, in the common risks, the things that sometimes we don't do enough of, or the things that we do too much of, that in the not enough category. So asset management. So maybe you have some ghost endpoints or any assets that nobody really access, and they just are available, and no function uses it. This poses a risk because either it's not being logged, or basically may allow an attacker to gain some access that is just not monitored or not being considered properly. So the idea is, you need to know what are your assets, and make sure that only the ones that are required are going to be available. The next thing is your resources and rate limiting in general. So if you allow anybody to make any number of requests they want and get any type of data, for instance, they need, or make different actions, or use your compute resources in an unlimited way, or consume large amounts of basically large volume of data, megabytes, and not necessarily the tables themselves. This could also be an issue. It could be a security issue from DDoS or any type of that sort of attack, or basically just exposure for something that is not intended. And then the last section here in excessive. So injecting data, excessive injecting data is any injecting data. You don't want to allow any injections. If it's SQL, LDAP, or a script or anything like that. The working through an injection typically is unintended. So there are cases where you may want to do that, but you don't want to allow any injection of data, and this is something that often is being missed. Data exposure, like we said before, if somebody doesn't have the privilege to access certain type of data, or if somebody asks for certain data, let's say an invoice, and instead you give them the list of invoices, and then it's on them to just separate the invoice they need. You don't really need to provide all the rest of the invoice list, or any other, or maybe a timestamp for the invoice, or a bunch of things that the requester did not make, was not in the request, you actually don't want to provide. Last thing is mass assignment. So technically, you can mass assign with one line of code a bunch of data from one table to another, which is effective. It's useful many times. It helps you replicate data. However, the problem is that many times the data that is replicated, it basically replicates everything, right? And some of the data that does not need to be assigned. So you need to be very thoughtful in which data you allow to be transferred. So mass assignment in general is it's kind of a red flag. So we want to avoid that. So out of those risks, we come with basically a bunch of best practices, and think about essentially, we're talking about doing more with less, right? So there are tools that can help you do many of these things, that can help you monitor. You can use AI to essentially come in and analyze what's in, what's out. But what I am talking about here in this talk is how can you actually do that without all of the tools. And this is not, it's not intended just for anyone that wants to build APIs with no security tools. It is also relevant for anyone that is using tools, because there is no replacement, at least in my eyes, for proper design and context for APIs. So the first thing that we want to do is, authentication authorization. Sounds simple. However, you'd be surprised how complicated it could be for somebody that may not have experience with implementing these type of systems, or basically textbooks implementations not necessarily adhere to advanced standards, for instance, OAuth 2 or 2.1 and so forth. Multi-factor authentication is something that is often an afterthought. However, MFA is crucial to many things that we do. It is crucial for authentication and authorization, especially on APIs. So this is something that we don't want to drop. And also within MFA is which type of MFA are you using? Is that a token? Is that SMS? Is that an email? What is that second factor, or the multi-factor that you're allowing? We can talk about it a little bit later, but this is something that we definitely don't want to drop. One other thing is random and not guessable IDs. So if you're using UUIDs or ULIDs or whatnot, it's pretty important to make sure that the IDs themselves are not guessable, because if they are, an attacker already has an advantage. They can already guess what the username or the ID is for a specific object, which already put things at risk, because it makes it easier for them to basically guess the next thing. The next thing is basically to deny access to basically by default, because in some of the APIs, basically, you either fail open or basically allow everybody to do certain action or certain access, and then block just certain entities. Typically, you should deny access by default, which is much more secure, and make sure that you don't forget certain entities. Role-based access control is basically built on that principle as well, to make sure that you have different roles. If it's a guest, if it's an internal employee, if it's staff, if it's engineer, if it's the testing team, or any of the vendors you're working with, each has to have their own role and their own list of basically access controls. One other thing is to basically check the authorization each time that any client requests access to database. And that is important because once you log in, you can make multiple requests, but we all know security is basically, I don't know, some people say like onion, some people say like cake. It depends on which side you are, but it's in layers. So if you pass the login area, and now you can start making access to different databases, then you have less barriers now to access the data. So you do want to check the authorization, which is basically the previous layer, every time you access data, to make sure that the authorization is still valid, to make sure that the authorization was not revoked because of some forbidden access or forbidden action. So that is something very important to do. And in general, we're looking here at the principle of least privilege. So we want to make sure that when you're thinking about anything access, anything authorization and authentication, you want to make sure that you, for instance, don't use admin accounts unless you absolutely have to. And this basically allowed with the role-based access control, that you basically remove anything default, anonymous, or any unused accounts in the system that access the API, that everything is very intentional and very well defined. And then manage the file and folders permission, isolate and segment any environment if you have multiple. So for instance, if things that you want to do at testing or QA or dev environment, you don't want to do in production, things that you want to do in one of your third-party partners environment, you may not want to do in another third-party vendor. So all of these things need to be very, very carefully thought through. Finally, here you want to limit basically the external users. So anything guest, vendor, third party support, and like anything that is external to your system, you definitely want to limit. It has to have limits. You can't really allow anybody external unlimited access. And lastly, there's a quick bonus here. So essentially, by doing that, by basically defining what are the roles, which data each of them are getting exposed to, and what can they do with that data, you basically gain data classification that can later use for, if you need that, for anything audit, for compliance, for a bunch of other stuff. So this is a bonus that you're getting from implementing an approach like this. And also limits the blast radius. So essentially, I wouldn't say if, but I would say when someone gets hacked, then hackers will basically, or malicious actors are going to get access to certain areas by implementing this principle. Unless they got access to the most privileged roles, if they only got access to some unprivileged role, the blast radius or the impact of the breach is limited, at least for a certain amount of time. If they persist in the system, they may find a way around it, but this immediately limits the blast radius in many instances. And last thing, it reduces liability, like I mentioned earlier, with segmenting environment between different third parties. You basically make sure that each organization, each role is only getting exposed to the data that they're supposed to. Access control. So here, basically, we want to make sure that requests are only being processed after the validation check, because otherwise, basically, you will allow a request to get to the data layer and expect it to be stopped there. There are several benefits to doing that. One is basically it's just more secure, because if you block the access before it even gets to the data layer, there is less likelihood of data exposure. And then next, basically your data layer is being hit with less calls and less requests, which affects velocity, speed, costs, and other things. So what you really need to think about here with access control is who is accessing, what do they actually want to do, and which type of data they actually want to get. And then when is the access being made, where is it, and how much data do they ask? So all these questions basically is basically the context of our request. So an example, if we're talking about a bank client, that wants to just log into their account and make a transaction, let's say move $1 million, when in the middle of the night, we stop here and then we say, well, what is the likelihood of that specific person to do that action in the middle of the night? This could be completely legitimate because this is how users work in that system, or it could be suspicious. So at least we can delay that until the morning. Where do they log in from a very similar area or an IP that they usually do, or do they suddenly do that from a completely different continent, which can also raise a red flag? And how much data do they want? In that specific instance, essentially, it could be the amount of dollars they want to transfer or anything like that. So again, when we're looking at the what, we're thinking about which action do they actually want to do. Do we want to view data? Do we want to create a new entry, update existing data, delete some data? This is all context for controlling the access to the resource. Now, one last thing here is that we want to avoid direct exposure, which basically aligns with the first point. We want to make sure that there is some kind of a firewall or a web application firewall or some gateway that will also help in reducing DDoS or any type of overflow attacks, and mitigate some code injection as well. So this is basically another layer here. Something else that you need to think about when we're talking about access control is the rate limit and the geo velocity. So this is actually quite interesting because this is something that many times is considered, well, this is too much security, so we don't really need to think about this. So I don't want to limit my API because this can actually break production, which makes sense. However, you still need to think about the context, the specific context of your specific API. So for instance, if we're getting back to that bank account, if we're talking about a user accessing their bank account remotely, would it make sense that we limit them with the number of access per hour, number of logins per hour? When you think about it initially, you may say, well, no, it's their bank account. They can, like any bank, they can come in and come out whenever, however time they want. But if you think about it carefully, what if I told you that they want to access their account 1,000 times per minute? Now it becomes, wait, that probably means they're not human, because a human can't really do that that quickly. So it's kind of a remote API, which could be a legitimate request. But maybe this is something that we do want to kind of enforce. And then you need to think about the rate limit here in two ways. So one, you can do a quota, and essentially after X amount of requests per time, whatever you want to define it, you just block it. So there are no more requests allowed. Another option is basically throttling. So essentially, don't block them completely. So it's going to be a zero down system. It's not going to be down, but the request rate is going to slow down to a point that we are going to force them to act like a human. So essentially, in that specific instance, we will basically make the connection or make the request time, the whole complete sequence, the response time slower, so the responses to the access is being throttled. This is it's very effective in actually mitigating some brute force attacks like DDoS, but it's also best practice to basically understand, is the entity that is trying to connect is really who they say they are? Is that really that same human that we assume they really are? One other point for geovelocity is the principle that between two geolocations over the world, you assume max speed, and then you don't allow a connection when that max speed is being essentially exceeded. an example here. Let's say a person is in New York and another person is in Paris. So if a user is trying to log in from New York and then 5 minutes later trying to log in from Paris, you would say the max speed between the two cities is, I don't know, Mach 3 if you have a jet, a fighter jet. So basically you can't do that in less than X minutes. But what if you are trying to do that? So you either block the request, make an assumption that this is basically not allowed, the geovelocity, it exceeds the geovelocity, or in some cases, you can say, oh, they're probably using a VPN, which could be completely legitimate, and they basically just change their location. These are things that needs to be taken into account. The last thing here is limit resources for access. So if somebody wants to use basically a certain payload, if a request that you expect is, I don't know, 1 kilobyte, but then the requester is being that the API is trying to send is 1 gigabyte, there's probably something wrong here. I mean the response. So either the request was done in a wrong way, or there's some kind of a malfunction, and we want to be able to limit the resources to what they should be. So so basically that cannot be abused in any way. The next thing is encryption. So we have encryption and transport, encryption and rest, and that's pretty much straightforward. So what we want to make sure is that basically the API requests and responses are all being encrypted in transport. And finally, that at rest on the database layer, the data itself is encrypted. So what we want to ensure is end-to-end encryption. It could be different algorithms in different ways, and the way that you do it is basically completely up to you. But this is one of the main principles here that we want to ensure. And one last thing, never roll your own crypto. We have libraries for that. Encryption is incredibly tricky. So you don't need to reinvent the wheel when we're talking about crypto. Next thing is data validation. So when you define schemas of data, you always want to make sure that the types, strings, patterns, everything is very, very well defined. So there's no room for interpretations or replacing data or data conversion unless it's absolutely necessary. And then even then, it's still well defined which data can be transferred or which data can be converted to which other type of data. And this will basically help not only in injection but also in cross-site scripting. This is it is a very important principle. And one other thing is for the schema object, if something needs to be read-only, just make sure that it's read-only, because many times the default is not. The default could be something else, and it could be laziness, it could be something else, or basically a naive assumption that nobody's going to make a change. If something is read-only, always make sure that it's always read-only. And there's a bunch of assumptions that you're going to make probably in your API based on that specific object being read-only. So this is something that needs to be secure and ensured. And the next thing is we always want to validate on the server side. We're all security professionals, and we know that doing these validation on the server side is super important. But I just wanted to call that out again here to basically ensure that everybody knows that this is extremely important. We want to mitigate certain injections, and most importantly, to hinder some of the recon efforts. So if everything is being done on the client side, there's a pretty good likelihood that reconnaissance efforts are going to be made on the data, and then using brute force or any other type of methods that can be exploited. The next thing is we always want to make sure it's very similar to the principle of least privilege. that the data that is being transferred, the data that is being requested, the data that is being exposed is only what's needed. So we don't want to overexpose any of the data. We don't want to do that not only in the data itself that is being exposed, but also one level lower on the verbosity for certain errors even. So think about it. Many times you log into, let's say, some financial institute account, you're putting a username and password. If you're going to put a username that does not exist in the system, they will never tell you that the username does not exist. They will always tell you that the username and password combination don't exist. And the reason is that you don't want to share information that only the first part of the login attempt was incorrect. Only the username was incorrect. So maybe the password exists, or maybe the password was not checked. But basically, you'll be able to enumerate the users on that specific account and run different users until you found one that actually exists, and only then you need to enumerate on the password. So it will basically help on the recon side. One other thing is another example is so that if in an API you're asking for the total invoice dollar amount, that is not equal to the sum of all items in your cart. Is a specific example for a shopper. So if we want to know that something costs $76.87, it's not equal to a sum of items that each had their own price, and the sum of them will actually be $76.87. So you want to make sure that you always transfer just the data that was requested and just the data that is actually needed for a specific action, and not build a function that essentially provides the list and then use it multiple times. One time use it for the total invoice, one time use it for a list. So each function should has its own use. And one last thing, as a bonus, it actually increases the speed as well, because if you are only provided what is required and don't build or allow requests that ask for more than what is required, then essentially you kind of boost the speed there as well. Documentation and login. So always make sure to basically document in full details, especially when you output logs and when you create a documentation itself. Put the usage, the functions, who owns it, how do we update, link to roadmap items. It's very, very helpful from the maintenance side, and also kind of put everybody in the same mindset of what is this thing, what is this API, what is the context, and pay special attention to documents and any M&A APIs. So if you're in a small company or a large company and you acquired another or merged into another company, now you're essentially in the same company with a bunch of other people, and you have your own API, they have their own API. What happens to documentation? You may document things differently. You may not understand the new API that kind of just added to your organization. These are super important, especially in these specific activities. One other thing is basically to review log and basically do log analysis, is to make sure that in your logs you don't have sensitive data. And that's different from the verbosity that we talked about earlier, sharing something that you should not share. But this is specifically about the data that is being outputted. You want to make sure that certain items or certain data items are not available in the logs. And if you need to separate it to a debug mode, this is probably what you need to do. But reviewing the logs basically allow you to, over time, learn if you have sensitive data in your logs or not. And obviously secrets and other stuff that you may see in logs. And then when, like I said earlier, when you get attacked, you can basically use logs to scope and damage, and basically get a full damage report and build a quicker report to actually see what went wrong. what exactly happened, how it happened, what was the vector. You may not have all the data right off the bat, but you will get a pretty good understanding of how things transpired, and then that will help you to basically harden or further secure your API. And it could be either a legitimate white hat attack or illegitimate black hat attack. So it really depends. The next thing is basically security assessment. So this is actually super important and very easy to kind of wave off. Design and peer review. So when you build an API or when somebody in your organization builds an API, it's very, very important to pay a lot of attention to the peer review. And many times it's pretty easy to come and say, well, looks good to me. I did not find any holes. All great. Let's roll. However, we do want to try to poke holes and we do want to ask questions, and not only to make sure that it is secure, but also to learn. So the person that designs the API may be senior and the person reviewing could be junior. You can actually learn from that. You could do multiple reviews and with multiple people at the same time, and basically learn why certain decisions were made, what's the logic behind them, and together try to think about better ways. Again, coming back to like an earlier slide, it's everybody's problem, and by sharing it, basically, we're reducing the risk and we're reducing the effort to solve it. And then the next thing we want to aim for, not only effectiveness, so that the API actually works, but also efficiency, that it reduces the resources, reduces basically the attack surface, and then also security. Obviously, make sure that all these best practices are being implemented. But last point is elegance. So elegance is kind of it's actually a fine point, because in elegance, humans, as we all are, we like symmetric things. We like beautiful things are typically very symmetric or accurately asymmetric, and essentially that helps us to manage things better, understand things better, and basically grasp the context of what something is and where it's at. So when you have beautiful code or beautiful APIs or APIs that developers actually love, they actually tend to be more secure eventually and more efficient and more effective. So elegance is a point to think about, to keep in mind. The next point is basically a dedicated security assessment, which is something that we implemented in our organization, which is extremely helpful. So once you built your API or you built a system or whatever that is, you want to basically create a big table and put all your risks in a table, categorize them, try to think about mitigations for each of them, create priorities for your risks. What is highly likely, like I put here in this table, what is like highly likely and very severe, all the way to very unlikely and very might be even benign. So try to make sure like which risk is more prominent than the other. And then don't be lazy, create tickets. It could be Jira, it could be anything else, but actually say and declare what is the risk, what needs to be done to solve it. If it's going to become work, that's something else. That's separate for later. But the ticket actually needs to exist. It needs to be captured properly on the design phase, so you know what you're doing and what you're not doing, and add any notes to it. So things that we want to take into account. These are essentially our best practices, but things that we wanted to take into account. We really need to think about the API audience. Is it a human? Is it a machine? Is it external, internal? This is one of the, I would say, the most important thing that you want to do for whenever you design an API. Is basically it sounds sounds silly when I say it, but we really want to know what it does and for who. And then think about the update cycles. Is this API is going to be launched and then nobody's ever going to touch it again because many third parties are going to use it and it's going to be very difficult to update? Or are we going to agree ahead of time to an update cycle once a quarter, or anything of that sort? Who is actually using the API is extremely important. The next thing you need to think about when you're talking about APIs, I don't want to dive too deep into that, but is it SOAP, REST, GraphQL? The requirements are different. REST is extremely common right now. GraphQL is picking up. No very hard standards there yet, but it really matters for what you need to do and how you want to secure it. There is no silver bullet. It's basically all depends on your specific use case. The next thing is basically we want to talk about like a little bit about security tests. So weave security tests into your test. So it's not just can you log in, yes or no, but all the principles we just basically discussed. You want to design tests for each of those, and I'll show you a bunch that I kind of put together. So you want to do the test before you launch, and then regular tests later on to see every time you make an update or from time to time, just to see that things are still going as planned and as designed. Key management, obviously super important. You don't want to, you only want to retain the keys that you need to use. And you want to be able to manage the keys properly. So secret management, like anything else. The next thing is third-party APIs. You want to really dive deep into any of those. And many times you may say, well, I dove deep and I found security flaws. What do I do? Do I not use it? I need to. So yes, it's a risk that you may eventually take, but you need to think about the mitigations. Okay, so what can you do about it? Can you at least shield or mitigate on your side to make sure the impact is much lower, or maybe work with that third party to improve their APIs and actually make it better with them together. Peer review, like I said, easy to wave off, easy to say, looks good to me, and that's it. But we really need to invest there as a part of your design. And in case of a third party, you really want to involve them whenever is possible. Sometimes it's not, but whenever it's possible, you really want to involve third parties. The next thing is when you're using tokens and expiration, so always think about adequate expiration. So for instance, if this is a shopper in a store, and shopping in a store typically takes a few minutes, maybe a few hours. If you generate a token, make sure that the token is not valid for a week, because you won't be able to do shopping for a week in a store. So token expiration must be adequate and basically a good fit for the type of usage you basically design for your API. And whenever it's required or possible, use a one-time token so you don't have to manage them. Sorry, part of it didn't load. All right. So the next thing is the recommended tests that I mentioned earlier. The things that you want to weave into your test, and I'm sure there are many other tests, but these are kind of handful of tests that were very effective and recommended. So first of all, you want to make sure that the API works. Great. And then you want to make sure that only the authenticated user can actually access the endpoints. So you can test things like brute force, for instance. And then if users are actually granted access only to necessary endpoint based on their roles or not. So again, principle of least privilege. And is only the correct information is being returned in responses or not. And what do you do with invalid requests? It's very important to reject them. You don't want to count them towards your cloud quota, for instance, because it's going to cost you money. You don't want to count them. You don't want to enable them or expose them basically in the data layer because that poses a risk. So even if it's a benign request and may not be risky, you still want to drop it. So if it's invalid, essentially just drop it. What happens in a simulation of any overflow, DDoS, or anything like that? And how does your API deal with legitimate traffic spike? It's very, very hard to discern many times between the two. But how do you actually make that distinction between, is it a DDoS? Is it legitimate? What do you actually do when it's legitimate? So these are all questions that you need to be answered during testing. And then mental simulation, that's kind of fun. So you either look at logs, which is great, or you literally grab a packet and use Wireshark or anything like that. Grab a packet, see what's inside. Sometimes you would be surprised. We make a lot of assumptions, but sometimes it's surprising. Try inject the code. It's not supposed to be working. You're not supposed to inject certain type of codes, but try it, see what happens, and make sure that everything has that all the data is being encrypted in many ways, and obviously that requests with no TLS or SSL are being blocked. So in conclusion, basically APIs are common. Security risks, security in API is really about context. You really need to understand what you're building, why, for who. It's not easy to answer these things for you as a consultant, for instance. So the design is one of the most important things in an API. Tools are going to help you. They're great, but definitely are not enough. There is no replacement for a great design. So even if you're using all the tools in the world, or if you're doing less and you don't use any tools, you can do a lot more by investing heavily on the design phase. Delete everything that is unnecessary, break down security into milestones, and do design review and security assessments. That's mostly it. I'm going to open it for questions now. So open for questions.
All right. Sorry, I had to take myself off mute. Somebody out there is playing video conference bingo, and they just got bingo. That was awesome, Nir. Thank you so much for presenting that. What's interesting that you start off the discussion as saying you're not a security person, but as someone who's been in security a really long time, it kind of swells that pride that you're bringing up a lot of really common security concepts that occurred in the original publishing of the OWASP Top 10 for web applications, and now we're seeing very similar kinds of concepts and safeguards against API security. And so really appreciate that coming from someone who's not a security person, more of an API developer. I love it.
A quick note, I am a security person. What I was saying is essentially that the company itself, Standard.ai, is a company. It's not a security company. It's a company that built AI products for shoppers and stores. I am responsible for product security. And
my apologies.
But yeah. Wait, you're muted again. I can't hear you. Wait. Oh, can you hear me? Are you hearing? Can you hear me?
I can hear you.
Okay, I can hear you now. Right.
Okay, great. Sorry about that. I don't know what happened with my earbud, but
no worries.
yeah, no, my apologies. I didn't mean to suggest that you're not a security person, but
Yeah,
coming
no,
from
no worries.
a non-pure play security space, such as that uh, um, retail software space that you're in, and I had a look at Standard.ai. It seems really, really cool. So one of the things that I'm sure that from the development side people are asking is, where do we find the people resources for this kind of stuff? So some of the things that you've noted that I think are such great ideas. One was that, reviewing M&A acquired APIs, and then the other one was, reviewing third.
Oh, you disappeared again.
That's kind of
Okay, you're back. Yeah, I think there's
okay.
just something wrong with your microphone, I think.
Yeah, something is my Bluetooth just turned off for some reason. Can you hear me
Yeah,
okay?
I hear you well. It's a
Okay.
different microphone now, but I hear you well.
Oh, okay, great. Yeah, so that was kind of my, just to repeat the question, was
Mhm.
who's doing that kind of review? Are you looking for a separate security team? Is it the developers themselves? Is it that are kind of doing that review for those non-internal peer review of the code, or is that somebody else that's doing that?
That's a good question. So whenever you're using a third party, basically a third party API, the people that are implementing the calls internally in the company are typically the engineering team. So you have like some kind of an integration team or a team like that, basically that it works with that third party API. So it's basically these guys that are actually going to do that. If you have the resources, if you have a security team and security engineers and all of that, that's great, and you can use them. But essentially, the first and many times last line of defense are the engineers that are actually implementing the APIs, either designing and building them or implementing a third-party ones.
No, that's great, and I think it's one of those things where we often overlook those um, little concepts that it can be part of that. So just going back to check to see if there's any other questions in the comments. I don't see any that come outright. Very cool. Some real practical applications of some very high level concepts that I think as security people we've kind of known for a long time, but how to articulate them to a developed audience, that was really fantastic. Just as a last go before we go into our next speaker, my own questions about some of these things was, you know that life cycle that you were talking about bringing in that peer review and introducing some of these concepts, has that extended your ability to deliver product and deadlines, or is it something that I've asked earlier, is it something that you're baking into the project, the timeline, and when you're going to be making code releases?
Yeah, that's actually a great question. So you probably saw there was one slide missing there. For some reason, it didn't load, and that's exactly that slide. So the principle here is that you cannot do everything everywhere all at once. You can't do that, pun intended. So what you can do is basically like any product management cycle and essentially build a roadmap. Weave security inside that roadmap. So for instance, if a feature is available at a certain point and you need mitigations for that specific feature, that probably you need to create those before the feature is available, but you don't need to have them in place way before it's available. So for instance, you can implement multi-factor authentication, and we all know that, through email is not great, through SMS may be better, and and a token is probably, push notification is probably best, or whatever other standard or framework you want to think about it. But initially, you can start with easy email, SMS, and then later on your roadmap, you basically need to create an item to improve MFA or enable other factors. So it essentially, security becomes a part of your roadmap. So it needs to be weaved into that. And that's very important to actually do ahead of time on the design phase,
Mm-hmm.
and be true to yourself over time and make sure it's prioritized properly.
You know what? As you said earlier, it's all in the design. So much is won and lost right at that beginning design. So thank you so much for bringing your insights here, Nir. It was a pleasure speaking to you. And tell everyone how they can reach out to you.
Sounds good. Yeah, Nir at Standard.ai. Happy to answer questions or help out. Again, we're in the security community. We're all in this together. We all help each other. So happy to help and use others' help as well.
Amazing. Thank you so much, Nir. Really appreciate you coming out to talk to us. And